All right, today we're going to talk about intersections of graphs. So, when graphing multiple quadratic and linear functions, there can either be one, two, or no points of intersection. So, if we look at linear and quadratic systems, we see here that on the first graph, you have two solutions because that's the graphs cross in two spaces. Then you can have one solution and then you have no solution, which means the graphs don't touch. If you have two quadratic equations written or graphed together, then they can meet at two places, or they can meet at one place, or they don't have to intersect at all. So a lot of times you can solve these equations and systems by hand, but remember this is a calculator active course. So we're going to let it do the work. So in order to do this in the TI-84, you're going to press y equals, and then you're going to enter in both of your equations into y1 and y2. It does not matter which equation goes in which. And then you are going to graph it. If you cannot see where they intersect, or you cannot see all of the intersections, but you know there is more than one, then you have to adjust your window so that you can see both of them. You can either do that by pressing the zoom button or pressing the window button and adjusting. Once you have your window adjusted and you can see both points of intersection or all of the points of intersection, then you're going to press second trace, and then you're going to go to number 5, which is telling the calculator to find the intersection. And then you're going to scroll as close to the intersection as possible, and then you're going to press enter 3 times. And then your solution or intersection will appear at the bottom of the screen. You will then repeat that for any other intersections that you have. So let's look at 2 examples. Example number 1. It says that we want to find the coordinates of the points of intersection of the graphs of the functions y is equal to x squared minus 8x minus 20, and y is equal to 4x plus 8. So I'm going to press y equals. And let me make sure I have the steps in the window so that you can see the steps as we're going. And we're going to type in x squared minus 8x minus 20. And then we're going to type in y is equal to 4x plus 8. All right, so once you do that, you are going to press graph. And sometimes it takes a little minute for it to load, but just be patient. You can tell it's thinking, the calculator is thinking, because it'll have that yellow circle near the battery. So now that it's stopped thinking or computing, in order for you to calculate anything dealing with the graph, it has to be visible inside of the screen. So you should actually be able to see it. So I see one intersection, but I can obviously see that there's going to be another solution that is going to be in the upper right hand part of the graph. So I need to adjust my window by either pressing window and changing my axis scale, or I need to press zoom and hit zoom out. So I'm going to zoom, and I'm going to press 3 for out, and then press enter, and I'm going to see what that gives me. So I realized that maybe I need to adjust my Y window a little up. So I'm going to press window, and for my Y max, I'm going to put 80 here. And I'm going to see if then I can see the other X intercept. All right, so now I see both of them. So now I'm going to calculate the intersection on the left. So I'm going to press second trace. I'm going to go to number 5 for intersect, and I'm going to scroll until I get as close as possible, and then I'm going to press enter 3 times. And here it tells me that my intersection is -2, 0. So that is a point of intersection. And then I need to find the other point of intersection. So I'm going to repeat the steps. Second trace, number 5, and then I'm going to go over to the other intersection as close as possible. And then I'm going to press enter 3 times. And I see that that intersection is 1464. All right, so I'm going to do the same steps for number 2. So for number 2, I'm going to clear these out. I'm going to press -3x squared minus 4x minus 2. And then for y2, I'm going to type in x squared plus 2x plus 1. And then I'm going to graph it. And from here, I really can't tell if they cross or where they cross. So I'm going to press zoom, and I'm going to go down to zoom standard. And what zoom standard does is it takes you back to the regular 10 by 10 graph. So you can see a little bit more clearly. So as you can see here, these two don't even touch, which means that here you have no solution because there is no point of intersection. A solution and a point of intersection are the same thing. All right, so now let's talk about quadratic models. All right, so there are many real life situations where there's a quadratic relationship between your two variables. So let's look at number 1. It says when a rock is thrown, its height above the ground after t seconds is modeled by the equation h of t is equal to negative 4t squared plus 50t plus 7 feet. Find the rock's height above the ground after 4 seconds. So using a calculator, we're going to clear out everything that was in there previously. And we're going to type in this equation. So h of t is the same thing as y equals. So we're going to have negative 4x squared. We don't use t in the calculator. Plus 50x plus 7. So it says find the rock's height above the ground after 4 seconds. There are 2 ways you can do this. You could go to the table by hitting second graph, and then you can go to 4, and you will see that the height is 143 feet. If you wanted to use the calculator, if you wanted to, you could have plugged in 4 for t and then simplified if you wanted to do it by hand and not use the y equals part of the calculator. Or you could press graph once you put the function into y equals. And once you let it graph, you can then press second trace. And then you can go to number 1, which is value. Now, when you say value with the TI-84, it means y value. So it's asking for the x value. And that x value is going to be 4. And then you should see the y value there, which is 143. So now let's look at part B. All right, so part B asks, how long does it take for the rock to reach its maximum height? Well, we already know that the key word maximum here is telling us that we need to focus on our vertex. And if we look at this graph in the calculator, we cannot see the vertex. So we need to zoom, and we're going to zoom out. I still don't see my vertex, but I see that I see both sides of it. So I'm going to then press window, and I'm going to change my y maximum. I'm going to change it to 100 just to be safe. All right, and I still don't see it, so I'm gonna go to window again, and I'm going to change the y maximum to, let's say, 200. Okay, so now I can see the maximum. So now I can tell the calculator to calculate the maximum by going to second trace, and then I'm going to choose number 4 because it is a maximum. So if I get as close to the maximum as possible, it looks like that the x value in which the maximum occurs is going to be about 6.5. So I'm going to pick a number or x value that's to the left of 6.4. So I'm going to pick 4. And as you can see, that vertical line pops up, and then I need to find another x value to the right of it. So I'm going to use 8. As you can see, when I use those 2 x values, that maximum is in between those 2 bars, so I know that the calculator will be able to calculate it. So when I press enter for the 3rd time, I see that it's going to take Remember, if it says how long does it take, remember we're looking at the time. And the time is in place of x. So it's going to take approximately, in 3 sig fig, 6.25 seconds in order for it to reach its maximum height. Then it says find the maximum height. The maximum height of the rock is going to be the y value when the x value is 6.25 approximately. And that y value is 163.25. And we know that that is going to be in feet. The next question, it says, part D, how long does it take for the rock to hit the ground? So the rock is going to hit the ground on the second y-intercept, or the y-intercept that is closest to the right. So we're going to press second trace, and then we're going to go to number 2, which is 0. And we're going to scroll as close as possible to the x-intercept. And that x-intercept is going to be somewhere between 12.5 and 13.1, somewhere in between there. So I'm going to pick a x value to the left. So I'm going to use 10. And I see that that vertical line pops up to the left of that x-intercept. And then I'm going to use 15 so that the other vertical line pops up to the right. And then I'm going to press enter again. And here we end up seeing that it takes the rock 12.6 seconds in order for it to hit the ground. Now you see where it says y is equal to 2e negative 11. That is saying that y is equal to 2 times 10 to the power of a negative 11, which means that you have to move your decimal back 11 times, which means that essentially this is going to end up being 0 because it's going to get really, 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 really small. All right. So now let's look at number 2. It says a landscaper has 50 feet of fencing to enclose a rectangular garden. It says where one side is an existing wall of a house. So suppose the two equal sides of are x feet long. So if I draw a depiction of how this is, let's say if I draw myself a wall of a house here. Okay, this is the wall of my house. I'm going to have a rectangular garden. And it says the two equal sides are x feet long. So these two sides are equal and they're going to be x feet long. If I know I have 50 feet of fencing, then that means that this remaining side here is going to be equal to 50 subtract both of those x's. So it's going to be 50 minus 2x in order to get the remaining fencing for that longer part. So part A says show that the area enclosed is modeled by A is equal to x times 50 minus 2x, and it's going to be in feet squared. Well, we already know that the formula for area is equal to length times width. So the length of this function, or the length of this rectangular garden, is going to be 50 minus 2x, and the width of the garden is just going to be x. So I already know that 50 minus 2x times x is the same thing as x times 50 minus 2x. It's just in the reverse order. So that is how I can show that by the work that I showed in the picture. So next it says find the dimensions of the garden of a maximum area. So remember, when you see that word maximum or minimum, that literally tells you to look at the vertex. So they told us that we're dealing with the maximum area. So I'm going to go to y equals, and I'm going to type in 50 minus 2x times x, or if you wanted to type it in as x times 50 minus 2x, it will still give you the same thing. All right, so you type it into y1, and then Because we've already previously adjusted our graph window, I'm going to press zoom 6 for zoom standard just to see things a little bit more clear. Okay, so I only see part of my graph, so I'm going to zoom out. And then I'm going to adjust my window so that I can see the maximum. So I'm going to start off with 200 as the Y maximum. Okay, so I need to go a little bit higher. So let's say if I go to 300. Okay, almost. I'm going to change that Y maximum to 350. All right, so now I can see and I can view it on the screen. So now I'm going to get the calculator to calculate the maximum. So that is number 4. We're going to get as close to it as possible so we can see what bounds we need to put on the X values. So the maximum is somewhere around 12. So I'm going to pick the left bound to be like 10. And then I'm going to pick the right bound to be like 15. And as you can see, that maximum is in between there. So we can press enter again. And it tells us that our maximum is at approximately 12.499999, which is approximately 12.5. So if you want to verify what the point is, if I see that it looks like it's about 12.5, if I want to make sure, I am going to go to table settings. And then I am going to have it start. I'm going to have it start around, let's say 10. And then I want the increments to be going up by 0.5, just so I can see what the height is at 12.5. Once I do that, I'm going to go to table. And then if I go down to 12.5, I see that the height is 312.5, which is what it told me on the graph when I found my maximum. So I already know that the accurate depiction here, or the accurate X value of that point, is going to be 12.5 and then 312.5. But you have to make sure you understand what each portion means. So the X value represents the width, and the Y value is going to represent the area. So when it says find the dimensions of the garden, that means they want me to find the length and the width. So if I know my width is 12.5, then I know that I'm going to have 50 subtract 12.5 times 2, because we have 2 of them. And that means that I will end up getting 25 as my length. So my dimensions are that I have a 12.5 by a 25. That is the area. So my length is 25. My width is 12.5. So we call it a 12.5 by 25. All right, if you have any questions, please ask. Have a great day.